Okay, this is your acid-base lesson 3. It's about conjugate acids and bases. So it's first important to note that there are certain compounds that are amphoteric. Okay, things that are amphoteric can act as an acid or a base. Okay, water is one of those things. Really, anything that has the capacity to gain or lose another hydrogen and be something that exists, that is called amphoteric. So water can gain a hydrogen and become hydronium ion, or it can lose a hydrogen and become hydroxide. So water is amphoteric. Okay, several polyatomic anions would be considered to be amphoteric as well. Let's say you had like H2PO4 -1. Okay, so this can gain a hydrogen and become phosphoric acid, or it can lose a hydrogen and become HPO4 with a -2 charge. So this would be amphoteric. Similarly, this could be amphoteric as well, because HPO4 -2 can gain a hydrogen and become H2PO4 with only a -1, because we gain a hydrogen, it's positive, right? It's a proton. Or it can lose that hydrogen and just become phosphate. So this is also what you call amphoteric. Okay, so that's what amphoteric means. It can, if something has hydrogen in it and it can gain or lose hydrogen and be something that exists, then it's amphoteric. Most of your hydrocarbons can't do this. Okay, so like methane, octane, butane, those things don't do this. Those are molecular substances. They're not based on charges. They're based on covalent bonding. These things are based on charges. And because they can gain or lose a hydrogen and change charge, they can be amphoteric. Okay? Hydrocarbons don't necessarily do that. Okay? Okay. Now, what happens? Well, if you have an acid, so in this case, we have acetic acid. This is just a fancy drawing for acetic acid. You have acetic acid. So it is an acid, okay? If you remember the formula for acetic acid, it's HC2H3O2, okay? So H, there's 2 C's, there's 3 H's off of one of the C's, and there's 2 O's. So HC2H3O2. That's acetic acid. And when you add that to water, that's water, okay? You get this reversible reaction. That's why it has this weird little arrow. It means it's reversible. It can go either way. So what happens is the hydrogen on acetic acid, because it's an acid, it's going to give away a hydrogen ion. So it's going to give that hydrogen ion away to the oxygen on the water molecule. So it will attach to that guy. And when it does, it brings its positive charge, right? So you have a positive charge now. So then you get hydronium ion, right? And the anion of acetic acid, which is just acetate. Okay, now if you added the charges up here and here, this is 0, this is 0, 0 plus 0 is 0. Over here, if you add the charges +1 plus -1, you get 0. You can't have a different charge over here than you have over here. So if a hydrogen or a proton is donated somewhere, you have to have a differential for what's happening there. They won't be electrically neutral species on this side, but when you add their charges together, they will be. The same charge that was over here will be over here when you add them together. Okay? Now, this was the acid. Acetic acid was the acid because it gave away the hydrogen. And water here is acting as a base, okay? It's taking on or stealing or accepting the hydrogen. So the leftovers of the acetic acid is the acetate ion. It's the leftovers after a hydrogen is gone. That's what's left over. This becomes the opposite of this. It becomes a base. So if acetic acid was an acid, the anion that's left over after the hydrogen leaves is the conjugate base. The base gains a hydrogen, so what it becomes the opposite of a base. It becomes the conjugate acid. Okay? Now, this acid goes with this conjugate base. So this is a conjugate acid-base pair. This base becomes this conjugate acid. So this is the conjugate acid-base pair. Okay? It's important to note that these two things go together and these two things go together. It doesn't necessarily always flow in the exact same way. So you have the outers that go together and the inners. That's not the way it works at all. I'm saying the acid, after it gives off a hydrogen, the leftovers become the conjugate base. The base, after it gains a hydrogen, becomes the conjugate acid. It flips, okay? So, a couple of examples. Okay, so if we had hydrochloric acid with water, okay? So what's going to happen, this is your acid. It's going to give that hydrogen to water, okay? So what's going to happen, you'll have the leftovers from hydrochloric acid, which will be chloride, and hydrogen will gain a hydrogen, water will gain a hydrogen, so it will become hydronium ion. So water here is acting as a base, okay? So the leftovers from the acid, after the hydrogen cleaves off, the leftovers becomes the conjugate base. What happens to the base after it gains a hydrogen? Becomes this. That becomes acidic. So this is the conjugate acid. So then these two go together, the HCl and the Cl, and these two go together, the water and the hydronium. So your conjugate acid-base pairs are HCl and Cl negative, and H2O and H3O plus. Okay, so what becomes the acid and what becomes the base? That's what you're telling me. So when you look at this next one, okay, so hydrochloric acid, you don't know this yet, but it's a very strong acid. So it always dissociates completely. So it gets one straight arrow. This next one though, NH3, this is something called a weak base, and we'll get to talk about what weak and strong means later. But for right now, just so you know, this should not have this arrow. It should have a reversible arrow. So NH3 is a common weak base, ammonia. We clean with it. If you clean with it, it's probably a base. So this is your base, and this time water is going to act like the acid. So it will give up one of its hydrogens to go over here. So what you end up with when NH3 gains a hydrogen, it becomes NH4 plus 1 charge. Okay? And what happens with the water, it loses one of its hydrogens, so it becomes OH negative 1 charge. Okay? Because it loses a hydrogen. So then this becomes the acid. So the base becomes the conjugate acid. And the leftovers, after the acid cleaves off one of its hydrogens, the leftovers is the conjugate base. So in this case, NH3 and NH4 go together, and H2O and OH go together. So those are the conjugate acid-base pairs. Or this is the base and conjugate acid, and the acid goes with the conjugate base. Okay? And that's the end of lesson 3.